gather before.
Sorry.
Scan the QR code so that we can keep track of your attendance. Remember, to be an active member of AMS, you have to have attended 2 meetings at least this semester or more. If you haven't gotten those 2 meetings, that's fine. You're still able to participate. Just remember, we want you to be as active as possible in our events.
So I just want to thank everybody who came out to the Halloween social event. It's a lot of fun. Our next social event is going to be the Deck the Met Lab, which we did last year. A lot of fun. We put up Christmas lights, decorate Christmas trees and everything in the Met Lab, make it look nice and festive. And that's going to be the 16th from 6 to 8. So mark your calendars for that.
Also, we keep those Christmas decorations up until like the end of January. So
Yeah.
it makes for a really good mood in the Met Lab. You'll see what I mean. Also, there's another announcement. I don't see all of you in the Met Lab very much. So across the hall, it's open at any time during the day, unless Davis Hall is closed, which is only on weekends. Everybody's welcome over there. Your ID card can get you in. Great place to work on homework or just fun with other meteorology majors as well. We'd love to see more people in there throughout the semester. So Evelyn, you have some fundraiser.
I just wanted to thank you guys for participating in both the bake sale and the t-shirt fundraiser. Some news on the t-shirts, we should hopefully have those in before Thanksgiving break. So just be on the lookout for like an email. So like when and pick them up.
Yeah, so I think we saw net around $600 raised between the two, and that's just the t-shirts, I think.
Yeah.
And more for the bake sales. Yeah. Thank you all for that. Our next event is going to be Susan Gasco from University of Alabama at Tuscaloosa. She's going to talk about communication meteorology. Any of our Met professors will tell you communication is the #1 thing in the science, whether it's broadcast operations, anything, communications is important. So right next to the forecasting one, this one's also going to be up there with important content. Keep an eye on the social medias. Discord, Instagram, Twitter are the main ones for potential off-the-wall study sessions or anything that might just be impromptu that could be cool later in the semester. The next big thing is we have a new executive board member on our team who we just added a couple weeks ago. This is Allie. Allie, do you want to introduce yourself?
Oh, sure. Okay, Allie Mills. I'm a junior here. I'm a transfer student too, so it's been a couple years, but I commute from Sterling. Ask me any question, I can try to answer if you guys have any questions. We're always here to help. But thanks for having me.
Yeah. So, Allie.
Okay, and then my last thing, so as we know, I'm the vice president of external affairs, and I've been working on this whole thing for the past couple of years. It's called AMS on Wheels, where I go to a bunch of schools and present for kids about meteorology. And I mean, not that this really affects any of you, I'm kind of excited. We just did one at West Aurora High School, and we have a couple students who are actually going to come here and get a tour from us personally, which is really cool. And then next semester we're supposed to do a bunch more, so stay tuned. If any of you guys want to get involved in that this or next semester, then just stay tuned for an email or Discord or anything. So yeah.
So without further ado, our general meeting today, I won't steal much thunder. Andrew Lyons from the Storm Prediction Center is here to talk about his career and a little bit about forecasting. So take it away.
Hey guys, how's it going? Everybody good?
Hello. Doing good.
Good. All right. Yeah. Thank you to your board members for inviting me here today. I'm really sorry that we couldn't make this an in-person thing. Unfortunately, with all the budget stuff, that's been really fun to deal with. Had to make it virtual, but there's hope in the future for making these in person. So I've kind of talked to some of my bosses and they're totally on board with that. So hopefully whenever the government is able to fund itself and pay me, we'll hopefully get one of these in person. But I want to extend an offer to all of you guys. If you ever find yourself in Oklahoma or storm chasing in and around, want to invite you guys, come to the National Weather Center, come see SPC. We'll give you guys a tour. We'll let you guys sit in on operations. So if you're ever in and around Oklahoma, Norman, just shoot me a message and my email will be at the end of the presentation. Kelvin also has my Twitter. If you guys don't follow me, you can. Just shoot me a message and we'll try and set something up. So just want to throw that out there. Let me start sharing my screen. But it's awesome that you guys are doing stuff like this. This is, we've got a really similar AMS chapter at OU that we do a lot with. And then we've also got some other groups that have reached out. So it's awesome to sit and work with you guys. And hopefully this presentation will be nice and fun. And I'll just kind of give you a rundown. I'll give you a little bit of background about me, kind of how I got started, my career path. And then I've got a forecasting activity. So did everybody get the printouts?
Yeah.
Okay, cool. There should be 3 of them. So you should have 2 surface maps and kind of a blank US map. If you've got your computer with you too, there's also a forecasting or a map drawing tool that we can use. And I'll show you guys some of that here in a second. Okay, my screen showing up pretty well?
Yep. Yeah.
All right, awesome. So, hey, I'm Andrew. I just turned 30 a couple of weeks ago, so I'm nice and old now, woohoo. But I grew up in Cincinnati, Ohio, and I've pretty much always loved weather and airplanes, and the two kind of just go together. One of my earliest memories is of a snowstorm in Southern Ohio. I was probably like 3 or 4 at the time, and the snow came up to about like my waist or chest height in one of the drifts. And so that was one of my first memories. So I think weather's always been ingrained in kind of who I am and what I wanted to do. So, you know, it's just some weather nerds are born that way, and I'm one of them. But a lot of my interests actually didn't start with weather. My original plan when I was kind of coming out of middle school into early high school was I wanted to fly Super Hornets for the US Navy. So I wanted to be a fighter pilot. And my grandfather on my mother's side was a fighter pilot. And then I've got a couple other family members that were in the military. So I thought that was going to be a way that I was going to go. Unfortunately, my eyes just weren't cut out for it. So I've got glasses on, as you can tell. My eyes are not very good. And so I didn't meet the military standard. And then last couple of years, they've let you started to do it with LASIK, but I was already too old for that at that point. So I ended up in weather instead. But I kind of seriously started pursuing weather like late middle, early high school. I was always interested in it. I really liked tornadoes, all the NOVA and the Discovery Channel shows, Storm Chasers. I grew up watching those, was always interested in that, you know, following Reed Timmer and the TIV and the Dominator and all that stuff. But it wasn't until about high school that I really started to kind of take things seriously and kind of plan my career path around weather. So I started really hammering the math classes, you know, calculus, AP Calc, things like that, and the AP Sciences to really kind of start setting myself up for a better college run so I could do meteorology. I picked OU. I did my undergrad there. I started in 2012 and graduated in 2016. I was involved in AMS, just like you guys are. And then we also have what's called the Oklahoma Weather Lab, which is a forecasting group. There's a little website, and then we would just forecast for certain parts of the state of Oklahoma. And then we'd make a little radio broadcast that they would play on the school radio network. So I got interested in forecasting really early, and all the opportunities in college allowed me to kind of transition that. And then, yeah, just some of my most impactful weather events kind of growing up. Like I said, I love snowstorms. I got tasked with kind of being the school closure guy at my high school. So anytime that there was snow in the forecast, everyone would come, you know, when's your forecast going to come out? What are you thinking for, you know, snow day chances and all that? And so that was a big part of that. And then my biggest kind of weather event that really kind of made me sure that I really wanted to study tornadoes and be an SPC forecaster was the March 2nd, 2012, the tornado outbreak in parts of Ohio, Indiana, Kentucky, and then stretching all the way down into Alabama, Mississippi. I was a senior in high school at the time, and I watched the entire event kind of unfold. I had forecasted the event kind of before then, after teaching myself kind of how to forecast, and I was like, okay, this will be a big tornado day. Let's see if I actually know what I'm talking about. I I still didn't know what I was talking about, but I was a little bit closer. So that was a really big event. And then there's just a couple pictures. So the picture on the left there, that's me in front of the Dodge City tornado in May of 2016. There's a little Super Hornet. And then that's Cincinnati, where I grew up. So do we have any Ohioans in the crowd? There's usually one or two in every school that I've talked to. Is everyone from like Illinois?
Yeah, pretty much.
Okay, I figured that this one would probably be a little different, but at OU, there's always at least like 3 people from Ohio, and then all the big state schools have at least 1 person. So, but Illinois is pretty cool in my book. So yeah, outside of weather, I live here in Norman. I've got 2 dogs, Ralphie and Sammy. Sammy's on the left, and then Ralphie's the little puppy. Don't be deceived, he's terribly naughty. But you see them being a bunch of goofballs down there. That's me graduating from OU in 16 with my family. And so that's right in front of the Weather Center where we took all our classes and where I still work today. So, but outside of weather, I'm a huge football guy. I played a lot of football growing up. My dad was a coach, and I've loved college football from when I was a kid. So I actually coached high school football for a couple years when I was in Colorado. And then I coached on a semi-pro and an arena football team too. So I was a special teams coach, mainly focused on like kicking and punting and stuff like that. And so those are some of my players down there from the Grand Junction Gladiators Colorado football team. Then obviously, as a severe weather guy, I love storm chasing. You saw the first tornado picture, but there's another picture of me storm chasing. I think that's the Texas Panhandle in April of 2015. Yeah, April 16th of 2015. So I love storm chasing. I always take at least a week or 2 off every May to go out and chase, mostly Southern Plains, but I'll occasionally get up into like Colorado and Montana and those areas. But yeah, it's just a super awesome, fun thing to do. I love to take the dogs storm chasing. They love it too. They love to bark at cows and run around in open fields. So yeah, and then I couldn't pass this one up, even though I'd never got to fly fighter jets. I am still working on my pilot's license, so that's the other picture there. About halfway done when I have the time and the money to actually fly, or the weather is nice. That's another problem that's here in Oklahoma, is that the weather is not always nice to fly. So about halfway done with that, but you know, obviously the weather and flying go hand in hand there. So that's just a little about my background. Oh, there we go. So for school, like I said, I was at OU starting in 2016. I did my BS in meteorology with a minor in math. And I would encourage you guys to, if you're interested in the NOAA Pathways program, if you haven't heard about that, that is an internship program that starts anytime after your freshman year that you can apply for. And basically it's a work study program. That's how I got into the Weather Service. And I would strongly encourage you guys to look into this as well. Usually the applications come out late fall, early winter, roundabout now, actually. Basically you just apply kind of like you would any federal job. And then they select students and you can go and work at an office during breaks or the summer and get real experience that then if you meet the criteria, you get selected for a full-time job. So that's what I did. I was selected for the Grand Junction, Colorado office. And then I also, since they have an upper air building there for weather balloons, I had to keep my certification, so I would work occasionally at the Norman, Oklahoma office, which is in the Weather Center there. Once I graduated, I went full-time at Grand Junction starting in 2016, and I was there until 2018. Really cool, a lot of mountains, a lot of snow forecasting. So didn't have a ton of experience with that, and fire weather too. But I learned a ton there. And then I was able to kind of apply some of that to my next location, which was Cheyenne, Wyoming. And that's the Cheyenne office down there in the bottom picture with the radar right next to it. If you think Wyoming is boring, let me tell you otherwise. That is the most awesome office I could possibly think of. There is every type of weather there except hurricanes. You got fire weather, winter weather, high winds, tornadoes, blizzards. I spent at least a couple nights stuck in the office because it snowed so much we couldn't leave the next day, which you know, it is what it is, but it's exciting weather there. So if you're ever interested in a weather service job and you see Cheyenne pop up, there's a lot of great people up there. It's a really fun town. There's a ton of mountain biking and hiking and stuff like that. And the weather is awesome. So you should definitely apply and tell them that I sent you. So I was at Cheyenne until March of 2020. When I was there, I started a master's degree online from OU in hydrometeorology. I got selected for the Storm Prediction Center in March of 2020. So great timing with COVID. That was fantastic. I couldn't actually go into SPC for like a full month during COVID. So that kind of stunk, but we got there, we figured it out. And then in that first year at SPC, I graduated with my master's in hydrometeorology and water resource management. So from OU. I'm still at SPC. I'm what's called a Mesoscale-Assistant fire weather forecaster, which means that I do a little bit of everything. And right now I'm being trained on how to do the outlooks for the severe outlooks. And so that'll hopefully get me the experience, and then I can jump into the next meso unit after that. And then I'll just plug in an aside too. If any of you guys are interested in grad school at OU, we do a class every year where we teach senior undergrads and graduate students. We call it the SPC class, but it's all taught by SPC people. And we just basically teach you how to forecast. We teach you all the techniques that we use every day. We run you through a bunch of cases like the one I'm going to show you in a little bit. And then we just give you the tools that you need to forecast. So if you're ever interested in some of the material with that, I'd be happy to talk to you guys more about it. Or if you ever end up at OU, I'm totally not recruiting there, I promise. We've got an awesome class and we've got a ton of lecture material with that. So, and I do some of the lecturing there. Okay. So what's a typical day at SPC? I know you guys have talked to Liz before. So I'll just run through really quickly kind of what we do and the number of shifts. There will be a quiz on all of this at the end, so you all better pay attention. I'm going to quiz you on the day shifts, but we've got 22 full-time forecasters. And we've got 5 fill-in forecasters, and we have 60 to 70 research and support staff. So be honest, how many people did you think were forecasters at SPC? Just shout out a number.
Wow.
Well, a lot of times people guess way higher. We've heard like 40 to 50, but there's actually only 22 of us that work full time. So we're actually about the exact same size as a regular weather forecast office. But we fill in all of these shifts every day. So like the day shift severe, we've got 3 people on from 8 to 4. And we've got another person doing outlooks and then 1 person doing fire. So we've got 5 people on the day shift, and then it slowly kind of shrinks as you go towards the evening, where we've got 5 people on the day shift, like 3 to 4 on the evenings and first part of the night shift. And then by the time there's the night shift, there's actually only 3 people there. But we're kind of staffed for severe weather the whole time, so we don't really surge people. Even on the busiest of the busy days, there's still only 5 people in on the day shift. And so can imagine that it gets a little hectic sometimes when you're trying to cover the entire US with 5 people, but you get really good at going through and looking at data really quickly. Yeah, we're just like any other weather service office. We're 24/7, 365. The old joke that we like to say is that weather never sleeps, and neither do we. With those midnight shifts, they can be a little hard on you, but I think it's really fun because you never know what you're going to get. And since there's only 22 of us, what you get really good at is figuring out what's going to happen sometimes several days in advance to several hours in advance. And you really earn a ton of experience really quickly. I thought I knew a lot coming in from the local offices that I was at for 5 years and all my background in storm chasing and other stuff like that. I was wrong. Sometimes on shift, there are hundreds and multi-hundreds of years of experience, cumulative experience on a single shift in terms of dealing with severe weather. If you think about kind of, being at a local office, you might have, 100 severe events a year, you know, on a really busy year, and you might only work, you know, 50 of those. And so over, you know, 30 years, you might work a bunch of shifts. But at SPC, every day that we work is a severe weather day. And that can be upwards of 250 to 300 days with severe weather probabilities. So from marginal all the way to the high risk. So when you work 200 days of severe weather in a year, in 3 years, you can have 600 severe weather shifts. And so you get really good experience really quickly. We call it taking reps because it's exactly like what it sounds. You know, you're sitting in that seat making decisions every day. You get really good at making those decisions quickly. So and it's not just severe too, it's fire weather. On the Meso-A unit, we do all the fire weather forecasts for the lower 48. So anything from days 1 to 8, we're forecasting whether or not there's going to be big wildfires out west, or, you know, grass fires in the plains and things like that. And we also do winter weather. So I'm the winter weather focal point, coming from my experience out in Cheyenne and Grand Junction. So I do a lot with heavy snow forecasting and lake effect snow and even snow squalls. So there's a ton of expertise. Some people at SPC have been there for 30 plus years. So you get really good at what you do just by doing it a lot. And so some of the pictures up there, guy in the purple shirt, that's Nathan Went. He's a Meso-A. He's issuing what we call a mesoscale discussion for the March 31st tornado outbreak. So if you can see the outlines there, that's the tornado watch. And then that little outline in the middle, that's the small mesoscale discussion for the Little Rock EF3 tornado. And then the person on the right there, that's Brian Smith. He's a meso outlooker. He kind of came up with the idea for those. So he's the person who's helping him to write that discussion. And then we've got a surface map. So we're going to do some surface maps today. So I hope you guys brought your pencils, and I hope you like those because they are super important. And I cannot stress enough how useful surface maps are for severe weather forecasting, because you're literally getting into the data, you're drawing on the map, you're looking at where these contours are, and it sounds silly, but by digging in yourself into that data, you really start to understand it more, and you can use that to make better forecasts. So if you aren't doing surface maps, you should be, and we'll do some today just for fun. So. All right, so this, like I said, is a kind of mini case that we're going to go through. We teach this in the severe weather class, and the goal is that you guys are going to design SPC style outlooks from scratch using the data that we give you. And hint, hint, it's not going to be a lot of data. So you're going to really have to use your meteorological reasoning. And I'll run through the data and we can ask a bunch of questions and kind of narrow in on that zone. But we're going to create an outlook. We're going to do some analyses and we're going to forecast if there's going to be severe weather or not. You guys ready to do that?
Yeah.
All right. Okay. So, like I said, we're going to start with a 13Z outlook. So we'll start with the 12Z data, and we've got soundings, we've got upper air maps, we've got some satellite, we've got some surface obs, and we'll go through and kind of look at each thing, and we'll come up with a game plan. And then I'm going to challenge you guys to see who can come up with the best forecast. Oh, and I forgot to mention, so congrats, there's no radar data. You're the only forecaster doing this, and good luck. All right, so we're going to start at 250 millibars. Have you guys heard the term the forecast funnel before?
Yeah.
Okay, right. So if you haven't, the forecast funnel is this principle where you apply broad reasoning and narrow your focus for forecasting. And you can apply this to the data that you're looking at to kind of gather your thoughts, and that helps with the forecast process. So I always like to start at the 250 millibar level. So this is roughly like 35 to 40-ish thousand feet, depending on the time of year. So this is pretty high up in the atmosphere. It's a couple miles up. It's equivalent barotropic, which really means that we aren't dealing with a ton of temperature differences in the layers here. It's mostly differences in pressure, and it's geostrophic or quasi-geostrophic, if you've heard that terminology before. Oh, and also some ground rules too, guys. If you see something or have a question, interrupt me, just let me know. And I'll try and stop periodically, but if you have something urgent come up, just let me know and we can sit and talk about something. But I'm going to let you guys digest this map for a second, and then I want you to come up with a couple features of interest that you see. And I'll kind of narrow the scope down. You're looking kind of from the Rockies towards like the Mississippi River. Those should be the main features that you're kind of focusing on. Okay. What's the big weather system that kind of stands out to you guys?
The large scale troughing around the Four Corners region.
Yeah, exactly. You've got a big broad trough there, sitting right over the Four Corners. It's, it's kind of in that good spot that we like to see where it starts to look like it's going to move east. How about the winds? Where are you guys seeing the strongest winds in relative to the trough?
Base of the trough.
Yeah, base of the trough, there's some 70s and 80s. There's even 100 down here. Did anybody look further northwest? Yeah. Yeah, so kind of west coast, there's also a second jet streak up here. So have you guys had quasi-geostrophic theory in terms of like your dynamics classes? Have you guys talked about some of the principles with that?
Some have, some haven't.
Okay. All right. Well, we can make it really simple. So troughs have vorticity, right? And vorticity is just the amount of spin that air has. You can get vorticity in two separate ways. You can get it through something called shear vorticity, which is a difference in the speed of the flow that those air parcels are experiencing, or you can get it from curvature, which is just a curvature in the height field. So troughs in the mid-latitudes are going to have most of their vorticity centered around the base. And we've got a jet streak around the base, but we've also got a jet streak further north, upstream. And so jet streaks generate vorticity too. So we should actually have two kind of vorticity maxima, one down here. Oh, actually, are there drawing tools on Zoom? There are. Hey, look at that. All right. So we've got two kind of vort maxes, one that's probably up there and one that's around there. So with quasi-geostrophic theory, anywhere that you're advecting higher vorticity, you can actually generate vertical motion. And most of it's vertically, it's up. So it's positive vertical motion. So anywhere that you have vorticity advection, you're generating vertical motion, and you're also generating height falls. So essentially lower pressure at that isobaric level, in this case, 250 millibars. So since we've got some better vorticity right here, just following the mean wind with some of that, we're going to move that vorticity down here eventually. We're also going to move this maxima in vorticity kind of over here. So kind of what we expect is that this trough is going to have two forces kind of acting on it. It's going to have vorticity moving from over here down into here, where we're generating lift and height falls. And we've also got some over here that where we're generating lift and height falls, and those should shift with time. So what we would expect to see with time, and we can go and look at this in a little bit, is that this trough will actually likely deepen and shift slowly eastward with time. And we can actually kind of see that in the progression, and I'll show you guys. But right now, what I want to kind of home in on is that you've got a couple areas of lift, and one of those areas of lift is going to be kind of over in this direction. Does that kind of make sense to everybody? Yep. Okay, good. If you haven't had QG yet, it will make more sense in the future. But right now, just think of it as that there tends to be lift where you have positive vorticity advection. And where you have vorticity most often in troughs is at the base. So anytime that you see winds blowing away from the base of a trough like this, you tend to get positive vorticity advection and positive lift. Okay, we're going to step down to the 500 millibar level. And same kind of thing. Why don't you guys just take a little bit of time to kind of digest that map? You actually do have a vorticity plotted on here. It's a little bit hard to see. It's kind of the dashed lines there. That's a little bit of vort advection. But same kind of thing. Think about what features you see. If there are any important features. Are there any features that you don't see that you would like to see if you're forecasting severe weather? I'm not hearing anything.
You guys know?
Go ahead.
Oh, no, I was just telling them they can shout it out.
Okay. What about those stronger winds? Where do they look like now at the 500 level? Kind of 250, they were out here a little bit. Where are the strongest winds at the base of the trough now?
There's southeast.
There's some southeast, yeah. Where's the strongest though? So those are going to be a little bit lower magnitude. They're going to be a little bit further west. They're kind of right here in the base of the trough. So if you look at the height gradient, it's a little bit steeper over here. You've got kind of a short wave and some stronger winds out here, but compared to the 250, let me see if it'll. Your strongest winds were kind of over here, but at 500, they're a little bit further west. So your jet streak is a little bit further west. So that implies that the lift at this level is a little bit to the west. But you've got kind of that same overall look. You've got a broad trough out to the west. A feature that kind of nobody mentioned too was you've got a ridge out in the east. So when you're thinking about severe weather, one thing that you should think about is what's happening farther east than my target area. Do I have a ridge? Do I have another trough? Why might a ridge be a good thing to have east of your severe weather zone?
It would bring in the moisture from the Gulf.
Exactly. Yeah, you've got high pressure at the surface, and that helps your return flow. And it also slows your upper air pattern. So when you have a wavy upper air pattern, the pattern moves slower than when you have zonal flow. And so that keeps your trough and your area of lift centered, over your potential severe weather zone, while you're also advecting that nice low level moisture further north. So yeah, so those things can definitely play into what you're looking for on the broad scale. Okay, let's step down to 700. So now we're getting about 3 kilometers from the ground in most spots. So you're going to start to see some isotherms on there. Those are the red dash lines. And now you're going to start to think about frontal features and temperature advection and stuff like that. Kind of sticking with the QG theory a little bit. Temperature advection can actually cause lift and sinking motion as well. So really quick, let me change the color here. Let me back up here for a second. Warm advection tends to cause rising motion. Cold advection causes sinking motion. Where might we be seeing warm advection with a system like this? And where might we be seeing cold advection with a system like this?
There's warm advection in north central Oklahoma.
Perfect. Yep, you got it right here. Let me draw on this. Yep, that's warm advection. How did we figure that out? We've got winds kind of along our isosurfaces that are crossing our isotherms. That means we're bringing warmer air from the south further north, and that's temperature advection. So thinking about what we just talked about, we had some, warm advection, which implies rising motion. So, oh man, let's see if I can, there we go. Warm advection. Okay. That implies rising motion, where we're advecting a warmer and potentially more moist air mass. We're kind of closer to that ridge where we were. So we've got some warmer air there. Where might we be seeing cold advection?
Like southern Nevada.
Yeah, southern Nevada, kind of all the way in through like the Southwest and the Four Corners, kind of in and around there. I guess I should have made that blue, but we'll just say cold advection. So cold advection implies sinking air, more stability. But what it also does is that cold advection in a QG sense can deepen upper level troughs. And if we look back, actually, I wonder if that will stay on. Yeah, it totally will. Hey, that's perfect. Look at where our cold advection is relative to that trough. So remember, we talked about positive vorticity advection generating height falls. Well, cold advection can also generate height falls. So when we've got that cold advection lined up directly beneath our trough, what is that going to do to our trough with time?
Deepen it.
Yeah, it's going to deepen it. What do we like to have for severe weather? Do we like to have a small trough?
No, not really.
No, yeah, we like a deep trough because that is lower pressure. That means we've got stronger winds aloft. So thinking about our thunderstorm ingredients, our shear, our lift, our instability, and our moisture, stronger, more dynamic systems tend to be deeper or tend to be better for severe weather. And when we have an environment that's actively helping to deepen that synoptic system, that should start to kind of ring your alarm bells. Does everybody kind of see how that works together? There's a lot of math that we're glossing over, which I'm sure everybody's happy about. But this is a really important concept that you can apply just by looking at a couple levels on a map. Whereas if you've got that system where it can potentially deepen with time, that tells you something about the atmosphere, that you end up with a feedback loop where you're deepening a trough, and a deeper trough can help play into your significant severe weather potential. Okay, let's go down to 850. So this is about 1 kilometer above the surface, a couple thousand feet. So now we're going to start to see moisture kind of mixed in with there. This is mixing ratio. So if you guys haven't heard that terminology, all that means is it's just the mass of water vapor per unit volume. So it's just how much water vapor is in the big air parcel behind you, that big square cubic meter, how much water vapor mass is in there. Typical values at 850, we like to see like 8 to 10. That translates to a dew point at the surface of like 50 to 60-ish, roughly. Anytime it's that deep. You can also figure out, if you're smart, what time of year this event might occur based on the moisture and the temperature that we were just talking about. But I want you guys to kind of digest this map a little bit. What new features have shown up?
Now I've closed isohydro for Wyoming.
Bingo, you've got a surface low. We'll just annotate that really quick. You've got a surface low right there. Okay, anything else? What are often attached to surface lows and surface features? Fronts, yeah, exactly. Where might we be seeing some fronts? We were just talking about warm advection and cold advection.
West Texas.
West Texas, yeah. What kind of front is that?
Cold front.
Yeah, you've got a cold front mixed in here. So kind of in this general vicinity. And this is probably a surface trough. Oh, there we go. I've figured out how to change colors, so we'll draw the proper synoptic front colors there for you guys. So yeah, you've pretty much, oh, that's not what I wanted. There you go. You get entertainment while you're learning meteorology. Is that what you guys expected today? So yeah, there's roughly a front somewhere in and around there where you've got the packing of the isotherms. So good call on that one. What is there another front that you guys see? Hint, hint, it might be red.
Warm front?
Yeah, exactly. You've got a warm front. Kind of whereabouts would you think that warm front is?
Through Missouri, Illinois.
Yeah, you've got a frontal system. There's a couple parts. So you've got kind of one in here, and then you've got another front that's probably like this. So it's a little messy because you're at 850, so it's not perfect, but you've got a couple frontal zones that are showing up. Probably got a surface trough that goes here like that. You probably got a weak surface low in here too. But yeah, so you're starting to see fronts. So just thinking about our classic severe weather kind of warm sector idea, where would you guys kind of start to hone your focus if you're worried about thunderstorms? Just based off that kind of frontal pattern and frontal surface that we're looking at. And this is rough. It doesn't have to be specific. Like what area of the country are you guys starting to think about?
Southern Plains.
Southern Plains. Okay, good. Yeah, that's kind of where the best ingredients are kind of starting to overlap. You've got your warm front, your warm sector right in there. You've got a big trough to the west of that. So you got lift and some other factors that are starting to come in there. And so you kind of narrow down that zone slowly, but you can kind of start to see where you might look based on that. Is that making sense to everybody? Is that clear?
Yeah.
Yes.
Yeah.
Okay. Okay, so that's the last ISO level there. Now we're going to take a look at some soundings. So we kind of decided that we wanted to kind of focus on the Southern Plains, but it's always good to kind of check around and see how your other soundings are doing. Soundings are a great tool. If you aren't using a bunch of soundings when you're forecasting, I highly recommend that you do, because you can just learn a ton of information. And it doesn't have to be severe weather. It's any type of weather. I would definitely recommend using soundings. Is everybody, for the most part, comfortable with looking at SKUTs?
Yeah.
Okay, kind of seen them. If we go over something, or if I say something, feel free to stop me or chat with someone else about it, because SKUTs can be really tricky, but they're super important. Okay. Oh, I'm skipping ahead here. So this is the 250 map, and then the star kind of marks the location of the sounding that we're going to look at. And these are all observed soundings at 12Z. So these are not model soundings. So here's Montana at 12Z this morning. What do you guys notice about this profile? Is it warm or is it cold? Yeah, I heard it. It's pretty cold. You're right at freezing in Montana. So when we're looking for severe weather, are we looking for freezing temperatures?
No.
No, yeah, exactly. So we might be a little far north. We were north of that warm front. We were probably north of the second warm front too. Remember our surface low up in Montana, or Wyoming, excuse me. So we're definitely on the cold side of things. So we're probably okay. You guys can let someone else do the snow forecasting for today. Okay, now we're down in Rapid City, South Dakota. That's where that star is right there. What do you guys notice about this one? A little warmer?
Yeah.
Yeah, okay, good. It's a little bit warmer. We're probably within that second warm front zone from the first 850 map. But what's our moisture look like?
Dry.
Yeah, it's pretty dry. Yeah, we're sitting, our dew point is probably about 5 to 7 Celsius. So that's, oh gosh, I'm trying to remember my unit conversions here. I think we're in the 40s there. So do we like dew points in the 40s for severe?
No.
No, yeah, it's probably a little too dry. So probably not. What do you notice about the winds though? Is that also looking good for severe?
No.
They're all kind of,
No. Why is that?
No shear.
Yeah. Okay, good. There's they're kind of all in the same direction. There's not a ton of speed shear, and they're a little bit, they change direction a little bit, but it's kind of snaky. There's not a ton. Remember that we've got that short wave there, so they're kind of feeling the influence of that one. So it's dry, it's a little bit warmer, but it's, we don't have good shear. So verdict, should we be worried about severe weather in Rapid City today?
Nope.
I'm hearing a lot of no's. Sounds like we're good. We're gonna move on. Omaha. Not the football play. Omaha, Nebraska. What do you guys notice right away?
Big nocturnal inversion.
Big nocturnal inversion. You win 100 points. It is inverted at the surface. If we're that stable, are you guys worried about severe?
No.
No, yeah. And it's also 32 degrees at the surface. So we're north of that warm front again. It's probably not going to happen in Omaha. North Platte, just for the sake of time, we'll go through this one a little bit faster. I'll give you a hint. It's the same pretty much as Rapid City. It's a little bit cooler at the surface. There's a little bit better moisture aloft, but it's still pretty cold. We've got deep easterly flow through like 2/3 of the atmosphere because we're on the east side of that trough. We're just not in the warm sector yet. So, all right, Denver, same story. It's just too cold. It's a little too dry. We're probably not going to have severe up there. And the winds are also, if you notice here in the low levels, you've actually got a front. So Denver is actually behind a surface front there. You're advecting cold air at the surface. Probably not going to be dealing with too much severe weather. Oh, interesting. We're in Dodge City now. What's the first thing that jumps out at you guys about that profile versus the other ones that we've seen? Moisture. And I think I heard someone say shear too.
No, but yes.
No, but yes. Okay. All right. You get a freebie. You got one that you guys got that one out of me. Yeah, that profile is a lot more moist. So our dew point is a lot closer to about 50 degrees Fahrenheit there, probably in that 48 to 49 C range. So if we remember, the warm front was kind of laying somewhere in like Oklahoma, Texas area at 850. So Dodge is just north of that. But we've got a veering wind profile. So what does veering winds, what kind of advection, temperature advection does a veering wind profile usually mean? Warm advection, right, yeah. And we just talked about warm advection being responsible for mid-level lift. And we like lift because that helps erode caps, that sets the stage for the atmosphere to produce thunderstorms. So are we getting any closer? Are we starting to maybe think that severe weather is potentially there for Dodge?
Yeah.
Yeah. Yep. I saw someone wave in the background there, so I appreciate it. Yeah, that's kind of the assessment that I would have, is that we're getting close to the warm sector there. So that's a site that we should remember. And then if you guys haven't done parcel lifts yet, this is one way to do them. Just on this QT diagram. So that black dot there is what I estimated as the LCL. And then the terrible purple line that's supposed to be parallel to the theta E contours or the moist adiabats. That's what the profile should look like. So we're not quite unstable, but we're starting to get there. We've got a little bit more moisture to work with. And you could even make a case that this point right here might be the most unstable parcel. Oh, hey, I'm skipping ahead. Right here around 750. But that might actually have a little bit of weak positive buoyancy aloft. But we're starting to look more interesting. Topeka, we're going back north. I think that slide's out of order, but it's not quite as interesting as Dodge. It's a little cooler. There is some moisture in the mid-levels, but with that much moisture in the mid-levels, what weather phenomena is going on probably at Topeka?
Cloud cover.
Clouds, yeah. Clouds, maybe even a little bit of rain. You got a little dry layer there, but you might have some stratiform cloud cover that's going on in Topeka. So it's a little too cold. All right, Albuquerque. Aside from this sounding being not quality controlled right, and bonus points to anyone that can tell me why it wasn't quality controlled right, what do you notice about Albuquerque?
Moisture.
Yeah, there's a little bit more moisture. Do we typically have moisture in New Mexico?
No.
Sometimes you can, but usually it's pretty dry there. New Mexico's mostly desert. You know, you've got the Rockies to the west that kind of block some of the moisture coming in. It's typically dry. And what's wrong with this sounding is that it actually went through a cloud, or probably better yet, a weak thunderstorm. The temperature is almost moist adiabatic. The relative humidity is almost about 100%. So it's probably entrained in a cloud, for those that are curious. So if you ever see a profile like this, that's probably not sampling the environment super well. They probably just didn't update this one. So, but you've also got some stronger winds aloft. So this is kind of towards the base of the trough. You're getting some of that better winds in the mid-levels. And what do you notice about the winds here? They're a little bit weaker. So you're starting to generate some of that wind shear. Okay, Amarillo. Anything stand out to you guys?
Surface inversion.
Yep, there's a big surface inversion. So that could potentially be an issue. You know, we're south of Dodge City now. So we're probably in that warm sector based on, you know, surface temperatures. We're a little bit higher in elevation, so things can be a little bit different. And I'll just tell you on this one, this is actually pretty good moisture for Dodge City, or sorry, Amarillo. So we're about a 50-degree dew point. It's relatively deep layer, about 100 or so millibars thick, which is pretty good moisture, but that's a big surface inversion. Now just asking you guys, what do you think that profile will look like later today? Do you think it'll look pretty similar?
No.
No? Okay. What do you guys think it'll look like?
Deeper moist layer.
Okay. Why?
I think the inversion will get lifted with time, and then as the surface temperature warms with diurnal heating.
Okay. Yeah, I think that's a good answer. But what do you notice about the air above that surface layer?
Right.
Is there a lot of relative humidity in that layer?
Very dry.
It's very dry. Yeah. So what happens if you give it too much sun and too much lift? What's going to happen?
Mixes out.
It's going to mix out. Yeah. So that's a pretty good moist layer for Amarillo, but that air aloft is kind of telling you the story. When you've got a big, strong trough coming in like that, you're going to be producing a lot of lift. If you're, you know, going to be clear and sunny, which this profile is probably supportive of, there's maybe some low clouds in Amarillo, but you're probably almost clear in the morning after a couple hours. Once you start to mix that, I think that dry layer is going to come down and really mess with the moisture in that. So what I think that Amarillo profile might look like later, we can just draw it on here, is probably something like, oh shoot. Oh, there you go. You saw the Norman one. It's probably going to look a little something like this. Oh man, it's not working. There we go. I swear I've used a computer before. So after mixing, your Amarillo profile might look a little something like that. So you're probably going to mix your dew points out there, but this is also a key piece of the puzzle. What kind of profile is that kind of hinting at? You know, we talked about a cold front, we talked about a warm front. Are there any other surface features that we might be interested in the Southern Plains that may have a dry layer associated with them? Dry lines. Yeah, there we go. This might be a hint that you guys have a dry line situation to deal with. Anytime that you've got a really deep mixed layer, That's just air that's behind a dry line, at least in the southern plains. So that's something to look at in future situations. Okay. Let's go to Norman. All right. Same thing. What do you guys notice?
Pretty moist.
It's pretty moist. Yep. Yeah, you've got dew points upper 40s, low 50s. The temperatures are low to mid 50s. What kind of advection do you guys think is going on in this profile?
Warm air.
Warm advection. Yeah, you've got a nice veering wind profile. What do the winds do with height from the surface?
Here.
They veer. And what else do they do?
Increase in speed.
Exactly. Yep. And what is that?
Here.
That's shear. Yeah. So you've got a warm, moist, and sheared environment. So if we kind of go back, this is kind of similar to the Dodge profile, but we're a bit warmer. We've got a much deeper moist layer, and we've got the shear that's in place. And downstream of the trough, that's the environment where we're starting to think, oh, okay, where are we relative to a potential dry line?
East.
East, yeah. We're east of Amarillo, so we know that dry line is, or potential dry line is to the west. So, and let's look at the analysis there. So we'll just assume it's a most unstable parcel. What do we have?
Hey,
We got Cape. Yeah. Remember our severe thunderstorm ingredients: shear, lift, instability, and moisture. We're generating positive buoyancy, y'all. That's what we like to see if we're talking about tornadoes and thunderstorms. So keep in mind, Norman starts to look pretty good. Okay, Little Rock. I'm just going to skip through this one. There's no moisture. There's no shear. There's a little bit of shear, but there's less interesting things. And Lake Charles, I'll just highlight this one. So Lake Charles is southeast of Oklahoma, or is southeast of Norman. We've got a southeast wind. What's the moisture look like at Lake Charles? I think deeper and better. Is that what I heard?
Probably.
Yeah, you can ignore the surface layer there. That's probably just a mistake too. You've got a really deep moist layer there at Lake Charles, in the mid-teens to mid to upper teens in Celsius. So that's 60s to mid 60s. So that's a good moist air mass, and you're kind of advecting that northward with the southeasterlies. Okay, Fort Worth, it looks a ton like Norman. You've got a good hydrolapse up here, so you've got dry air aloft. If you have dry air aloft, what does that do to your temperature profile?
Steepens it.
It steepens it, and that's called a lapse rate, right? Right? So lapse rates are important for buoyancy too, because the steeper you cool, or the faster you cool your temperature profile, the more instability you can generate. Oh, I thought I had a profile on that one, but I know I've got one on this one. So this is Del Rio, Texas. This is Texas Big Bend. Have any of you guys ever been down there? No. It's an interesting place if you've never been. It's you and 10,000 lizard friends, and that's about the only thing around there. So if we kind of compare these, to the last couple, it looks kind of similar to Norman, but what do you notice about the surface temperatures? They're warmer. Yeah, exactly. So you're really solidly within that warm sector now. Your dew points are really good. You've got starting, somewhere around like 970 all the way up to 800 millibars. So almost a 200 millibar thick layer of good, warm, moist air. And if we look at the wind profile too, we're veering. So that's our warm advection. That's our lift. We compare that to where we are in the trough. We're downstream of the trough, so where all the lift and all the strong winds aloft are coming out. If you guys had to pick a profile Oh, and there you go. There's our buoyancy. That's a lot of cape. We like that. What do we have to worry about though, if we're thinking about thunderstorms?
Yeah, yeah.
The cap, yeah. So we've got a cap. So what are some ways that we can get through that cap?
We can warm the surface.
We can warm the surface, perfect. And it's 12Z in the morning, so we know that we probably are going to warm the surface because it's early in the day. What are some other ways?
Ascent.
Ascent, yeah. Where do you get ascent relative to a trough?
Downstream.
Downstream. Where are we?
Downstream.
Downstream. Whoa. What other things can generate ascent other than troughs?
Up front.
A front. Are we near any fronts?
Man.
Eh. I don't know. What are we maybe near two types of fronts that we might be interested in?
Yes.
Yeah. Yeah, we're downstream of a cold front that we kind of analyzed over parts of like West Texas and potentially ahead of a dry line. So we're starting to kind of look a little more interesting in a certain part of the country if you're following along. Again, our ingredients, shear, lift, instability, moisture. So we've just checked off 3. And looking at the profile, you see the winds increasing with height. We're downstream of that trough. That's all 4. That's our slim. That's our 4 ingredients that we look for storms. So be thinking, where might that environment be? And then this is Midland too. What profile does that look the most similar to that we've gone through so far?
Amarillo.
Amarillo, exactly. So if we know that Amarillo might be representative of a dry line sounding, and that Amarillo will probably mix out, we can probably apply that same logic to Midland later in the day. So do we think Norman is going to mix out with the dry line?
Oh.
No.
No, but we think Amarillo and Midland might. So where might our dry line start to show up later this afternoon if we're thinking about targets?
West Texas.
West Texas, there you go. Kind of somewhere in between those two. Somewhere in there. And so the awesome part that we just did is that you guys technically just made a forecast by only looking at a couple maps and a couple soundings. And all of this is observational data. None of this is model data. We're not looking into the future with anything that's being computed. You're making that forecast for the next 12 to 24 hours purely off of observations. What do models not handle super well all the time? I'll give you a hint. It's observations. But you as a human forecaster can use those observations that you've looked at, and you can extrapolate those in the future and then compare that to model guidance. So I'll tell you that this case, there was no model guidance. So that should also give you a hint of when it was. But so I couldn't even generate any if I tried. But this is how, you know, certain folks have done this for many decades, and you guys can apply those same concepts even today when you have the HRR, the, the HRRR, the RAP, the NAM, the GFS, the FV3 is everybody's favorite nowadays. You can apply these same concepts to forecasting. And I would strongly recommend it because it's way better than just, taking pure model output. And then we'll skip over El Paso because there's our dry line sounding. We are definitely west of the dry line. Arguably, we're close to a cold front too with that northwest wind. So we've got a cold front, a dry line type feature kind of coming in. We've got our fronts, we've got our surface low. We've got our moisture, we've got our instability. We should start thinking severe weather. Okay, so here's our first surface map. Be honest, is that kind of what you guys envisioned? Or I guess this is the hour before your first surface map there on the ground. This is the 12Z, you guys have the 13Z. But are there any features that kind of stand out to you guys? What about the temperatures? What do you think about the temperatures in, say, the Texas Panhandle?
Pretty cool.
It's a little cold. Yeah, it's a little colder than we thought. So that's something that is maybe something to think about. If you guys aren't familiar with this, the colors here represent the IFR. So red is like IFR conditions for aircraft. So that's cloud cover, low visibility, fog, essentially. Whereas blue is MVFR. And then you can see on some of the other ones, you've got partial clearing and stuff like that. So there's a little bit of low cloud cover ongoing. There's a little bit of fog, even at Amarillo, it's 39/37. But what do we notice about the air mass down over South Texas?
Warm and moist.
Warm and moist. So remember at 850, we're about a kilometer up. So our warm front was kind of somewhere in this general direction. Where does it look like our warm front is at the surface?
Where you've got the easterly component to the winds.
Yeah, exactly. Somewhere kind of in this central to south central Texas area. That's kind of where our surface warm front is. Would you say that we have a dry line at this very moment? Based on what you're seeing kind of out here, eastern New Mexico, West Texas? I'm hearing some hemming and hawing, some nah, not really.
It's a diffuse one.
Kind of.
Yeah, there's kind of, you can kind of see it's dry here, dew points in the 20s, low 30s. There's even a 19 down here and a 10 down here, and kind of in the 50s. So there's probably a feature that you could draw, and we probably will draw that here in a second, but I wouldn't call it necessarily a dry line at the moment. Dry lines, they take time to develop. Excuse me. So you probably don't have one right now, but you're starting to get some surface features. Here's the satellite for that time. So it's still coming off of dark, so we can't see super well. What do you notice about like most of Texas and Oklahoma? There's clouds. Yeah. So we're a little worried about that. But what happens to the clouds the further west you go?
They clear out.
Yeah, they kind of clear out. You see some breaks like down here, around Midland, there's some breaks. There's some stuff even south of Amarillo and north of Amarillo too. So your cloud layer is not very deep over there. But when you've got the moisture kind of coming up, that's something to think about. Okay. So just some initial thoughts. Be thinking about where we had our upper level lift, our upper level systems, kind of the trough. Remember our surface low up around 850. What do you think is going to happen to that surface low as we go later in the day? And just a reminder, we think that upper level trough is going to deepen. So think about the interconnectedness with your surface low and upper level systems. Where do you think the best moisture is? Where do you think the best lapse rates are? Where did we find the best instability on some of the soundings that we looked at? What do you think is going to happen to our vertical shear with time? Just be thinking about the profiles that you saw and about the upper level system and how that might change in the future. Okay. So we're going to do this one first here. So you guys should have the 13Z maps, right? Okay. I want you to spend just a couple minutes kind of sketching out the fronts and stuff on there. If you've got time, go ahead and feel free to do the surface pressure. But really just kind of take a minute to think about where those fronts are. Kind of draw your zone of where you think the warm front is, where the dry line might be, where the cold front is. If you have a surface low in that part of the country, where might that be? And I can step back and forth, take a look at any old data if you guys have any requests or anything like that. We'll just do this for here. We'll come back at we'll come back in 5 minutes and see what you guys got. And you guys can work together. This is not homework or anything like that. Discuss and find points of interest with your neighbors and friends. Here's the map itself too, if you don't have a copy.
I think I found where the cold front is. Starts a little, southwest of Texas. Yeah, and like this, this southwestern portion right here. Yeah, that's temperature, that's. Yeah, I just do that. Yeah, see. Yeah, you see. That's one right there, so. Yeah, that's gonna drive. Very, very, so that's what. Jerry saying that. This world is goes away, like those drives down was, you know. And I'm just going to. It's more fun. It's Southwest, this is 33 and 61 south. Yeah, I actually haven't had it so on that branch got there. I know. Yeah. Yeah, it seems like that. It's
All right, guys, do you like the limited data, or would you rather have so much more data? I'm curious.
So much more.
Oh, wait. Yeah, that's what I get every time, and I hate it too. But we're just gonna pretend like all of the data disappeared. All you had was a printer and some maps, and that's it. You know, IT failures.
I'm still working.
Yeah, I've seen you like, I should. We were talking earlier. Yeah. The 360 presentation, or the extra credit. Yeah. That's the guy doing.
We might have.
Until tonight, it won't. I think they'll, I have to refer, I have to do it. So actually. I used to study guide, I covered all. Well, yeah, I use it. I mean, I know the study guide, but there were some questions. Yeah, there's something. You're do they? Yeah. You know what I mean? Yeah, I heard it does. Yeah, not the best, but it's one.
Also might.
Yeah, oh, yeah.
Right, it's 6:45. So how'd you guys do? I know that's a short amount of time. I promise I can't even do a surface map in 5 minutes. It's just way too much. But did we find kind of the features that we were looking for?
We're trying.
Yeah, you're trying. That's okay. You can keep working on it a little bit. But just real quick, where are you guys kind of focusing in on? Like, what's the biggest area that you guys are kind of focused in on right now?
Yeah, blue color pencil.
South Texas.
South Texas. Okay, good. Yeah, that's kind of where I've been leading you. So good to hear. Any other areas that jumped out at anybody? Sometimes there's severe weather in multiple spots.
Like just to the southwest of where like the Oklahoma or where Oklahoma meets the Texas panhandle, like at the point.
Oh, okay. Yeah, perfect. Yeah, that's a good one too. So what drew you there?
What was that?
What kind of feature grabbed your attention there the most?
Well, there's a dry line and I almost have like a secondary warm front there too, where they like
Okay.
intersect. I don't know if that's right, but that's what I have.
Oh, that's the fun part. You're not going to know if it's right until the end. All right. So you guys can feel free to keep working on your surface maps, but we'll go ahead and step through some more data because this is clearly not enough. We need more. So here is gosh, what time is that? 13:45. So that's like 7:45 surface map or a satellite. We're now like bright daytime. What are those clouds doing? Anybody?
Clearing.
They're clearing. Yeah. I heard, someone mentioned South Texas as being a severe weather area. You've got some clouds there still, but on the west side, you're starting to clear there. The Oklahoma-Texas border region was also mentioned. Got some clearing there. Even some clearing up into like eastern New Mexico and some of those areas. Any type of cloud stand out to anybody?
Stratus.
Yeah, a lot of stratus. That is mostly what this is mostly stratus. There are any interesting features within that stratus that might key in on something? If you guys can see that, I forgot that you're on a projector, and it might be kind of hard to see.
Are you talking like the sharp edges on the western side?
Well, that a little bit. That can kind of tell you where there's some deeper moisture, but how about right here, right on that Texas border region with Oklahoma? What type of clouds are those?
Gravity waves.
Yeah, they're essentially billow clouds, which are manifestation of gravity waves. So if you didn't know, billow clouds tend to align with the mean flow in the low level. So our winds from our surface map are kind of like this. And so they're roughly parallel with that. Those billow clouds indicate areas where you've got a lot of vertical shear. So you've got some billow clouds right there. They also indicate stability. So that's something that you have to think about, that they're stable, but that means that the air mass there is stable, but strongly sheared. So just something to keep an eye on with time. Okay. Oh, wait, you're not supposed to see that first. Shoot, where'd it go? Oh, here we go. We're going to make an outlook. So, you guys, there are two options that you can do. If you want to, you can draw on the blank paper. Or if you have your computer and you're interested in, I can show you, there is a website. I can put it in the chat. Let me
have extra blank maps that I knew we'd be drawing, and I know that we're meteorologists, so extra maps up here.
I'll minimize this really quick. There we go. Okay, so here is a website. It's wxwatcher.us/map www.spe.gov/outlook if you've got your computer. This, you guys can still see my screen, right?
Yeah.
Okay. So this just lets you draw the outlook in kind of like a computerized way. It's totally up to you guys if you want to draw it on the map or with this. So this was developed by another meteorologist at the SPC, Andrew Moore. We did this for like outlook practice when we were being trained on how to do the outlooks. So if you want to, you can totally use this. And you just kind of select your drop down in outlook mode, and then you click this little button over here and you can draw a polygon. So like here's a big marginal risk or
Thanks.
slight risk, something like that.
Hey, Andrew.
Yeah.
You want to quickly explain, we've got some time, everybody's enjoying this, so don't worry about time.
Yeah.
Do you want to quickly explain how you guys come to your categorical probability or categorical outlooks based on probability?
Sure. Yeah, so that is a great point that I did not think about, because we were just going to do the categories. But so if you guys didn't know, there's actually underlying probabilities that define what our category is for severe risk that day. Let me find SPC Outlook probabilities. I did not come prepared here. So yeah, here we go. So each outlook category, so we will do is kind of the sum of the various parts. So tornado, wind, and hail. And we have a matrix that we use. A lot of people think the categories came first because that's all that we published, but it's actually the probabilities that drive the category. So if for instance, on the case that we're using today, if I think that there's a 10% chance of a tornado within 25 miles of a point, that's going to drive the outlook category. A 10% is an enhanced risk or a level 3 out of 5. So let me see if I can find that table really quick. Yeah, here we go. So this is the kind of where we derive our categories from. You can see the tornado, the wind, and the hail here. So the day one outlook probability, and then the color fill is the categories. So when we're forecasting, we are actually kind of thinking about what type of event is going to occur, whether or not we think that it is going to have higher probabilities of tornadoes or wind or hail. And those underlying probabilities define what we do for the category. But the category is also special because, if it's a high risk, that means something to people, right? We don't issue a bunch of high risks all the time. So we want to reserve those for days that we think are going to have violent tornadoes or really strong derechos, things like that. We actually can't even go high risk for hail. It doesn't happen. So because our probabilities peak at moderate with that. So you can use this. There's the link. So spc.noaa.gov/miscellaneous/spcprob_outlook_info.html. I can leave this up too if we want to talk about that more. Does that kind of answer your question, Kelvin?
Yep, thank you.
Okay, perfect. So where was I here? Yeah. So if guys go ahead and just select whichever one you want to do. If you want to draw using the tool, does everybody have the URL loaded up for that?
Yeah.
Okay. And if you want to draw on the map too, in hand, that's perfectly fine as well. But go ahead and start to draw a 13Z convective outlook. So I'll leave the probabilities up here.
You want us to do from general thunder or just the severe probability outlooks?
Just do the severe. So start at marginal. which is that dark green color, and then go all the way up to whichever category you think this event is. And I'll just ask too, what do you guys leaning? Do you know? Because this totally could be a bust event. I would be a jerk if I did that, but it could be. You guys might never invite me back to talk more if I gave you a bust, but it totally could be. What kind of outlook probabilities or what kind of categories are you guys leaning? Do you think it's going to be a big severe weather day?
Potentially big.
Potentially big? Okay. Anybody on the opposite end? You're not sure? You think it might be kind of a dud? No, nobody? Okay. Darn, I haven't done enough to trick you guys yet.
Yeah.
Just for fun, I'll do what I think it's going to be too, even though I know. So I'll try and throw you off.
I just don't think there's something that's.
What's the maximum risk category that you guys have gone so far?
I've got an enhanced.
You got it enhanced? Okay. All right. So we must be pretty interested if this is an enhanced, right? What hazards are you thinking about? Hail?
I'm also thinking hail as well.
Okay. Okay.
I think there's gonna be tornadoes.
You don't think they're going to be tornadoes, or you do? Okay. Okay. I might also do an enhanced too. I don't know. I'm gonna see what it looks like.
I don't know where the comes from. I kind of adjust the arms and skin care.
Are you?
Ah.
I know, a little bit further right.
I
That's just my
don't
idea.
know much of what I'm doing. I've only had, like, I want to say, I've only had, isn't that one place? Or is that EA? The EA. You have more than I do.
I am too.
All right. Where do you guys have your enhanced? I'm just curious.
In the middle of that.
Yeah, from Wichita Falls to Abilene, yeah.
Okay. Okay.
Oh, yeah.
I have my whole
And don't worry, you're going to get a chance to refine it too later in the day here. You get to issue the 13 and the 1630Z. Because
We're gonna-
your replacement for work called in sick. Oh no, you have to do all of the forecasts.
We're good.
I think
All
All right, we'll give it just a few more minutes and then we'll keep going.
It's really weird. I was you know what? Now it's. Yeah. Yeah. I just didn't watch those ones. I mean, I read that. Whoa.
Yes.
Whoa, whoa.
What? Just curious. I'm just seeing, this is how we kind of experiment with our outlooks. We're like, whoa, what's
Yeah.
that doing?
No.
Okay, you got it.
Probably. Oh,
Okay.
we scared him off.
Actually, I'm gonna leave it. So, all right, pencils down. No more changes. All right, let's see here. Okay, so we got our 13Z outlook. We had a couple enhanced. Give me some other. What did you guys have for your outlook? What category?
Slides.
Light. Okay, a lot of slides. Did anybody have a marginal? Nope. Okay. Anybody moderate? Anybody higher end? No? Okay. Wow, you guys are like locked in on slight and enhanced. Okay, cool. What was one factor that prevented you or oh man, I don't want to give too much away here. Why did you choose slight versus enhanced? Just someone too cold?
Early.
Okay. Why did someone choose an enhanced versus a slight?
That Big Ben sounding.
That Big Ben sounding? Yeah, you guys liked that one. That was a lot of cape. Yeah. So, okay. All right. So it sounds like we've got some people who are kind of on the fence, like conditional versus like, I don't know. There's still a lot of flies in the ointment that we aren't sure if it's gonna work out. Well, the good news is there's more data coming in. All right, so here's 14Z. Any big changes on the surface map? I don't think you guys have a 14Z surface map. I think your next one is 16. So I think these are just on the screen. So any big changes that you see compared to what you did earlier in the day?
Not really.
No. Okay. Yeah, it's kind of similar. Only real change that I noted was it's a little bit warmer, but there's still a lot of clouds in the south. It's a bit drier out in West Texas. That potential dry line might be shaping up a little bit. There's hints of a surface low in southern Colorado, but generally it's pretty similar. And sure enough, here at 1445 on the satellite, it doesn't look too much different. But we got a couple things that are maybe of interest. So look down here at some of the stratus. What's happened to some of the stratus with time? Anybody? Here, we can go back a little bit too. There's the 13, there's the 14. How has that changed?
Started to clear a little bit.
Okay, yeah, it's starting to clear a little bit. So we've got some better clearing. You've noticed, what does the structure look like? Does that look like stratus clouds still?
No.
No, it's kind of changing. There's a bit of a character change. This is something that we look at a lot at SPC when we're looking at satellite, is we're looking at what those clouds look like and how they change over time. So I'd argue we're probably getting more stratocumulus type clouds out of this. And you know, if you remember your cloud types and what they mean, stratus is typically stable, you know, and, you know, layered from the Greek or whatever, it's Latin. I'm very scholarly if you can't tell. Versus your cumulus, you know, which is more heaped or clumpy. And so it's starting to get that kind of clumpy look. Remember, cumulus is kind of indicative of instability. Our Del Rio sounding down there was the most unstable. So the atmosphere is kind of maybe starting to respond to some of that. Let's take a look at those billow clouds that we had talked about earlier in the day up here. What are they doing? Are there more or less of them?
More?
Yeah, there's more. Yeah. And we're starting to see some of that strongly sheared but still stable air mass show up a little bit better. That's an area to watch. You should watch that area. Okay. Let's keep going. Okay, now it's 15Z. It's 10 a.m. Central Time. Any big changes in the surface pattern? Nope. It's still pretty similar. But what do we notice about southern New Mexico? What have the winds done?
They veered.
They veered, yeah. And I think someone else just said it too. Temperatures are a little bit warmer. They've gotten stronger. They veered. They're all out of the southwest now. So we're starting to heat up during the day. Remember, that area was mostly cloud free. So we're getting the most sun in that area right now. So we're warming up the quickest. We're just talking about, you know, where's our dry line going to start showing up? That might be the place because that's where we've got the dry air. We've got some stronger southwesterly winds. So this might be the very beginning hints of our better dry line that's starting to come in. And then here's the 15, roughly 16Z satellite imagery. The bands here, that's just bad data. And it's kind of missing some there at the bottom. So if you notice, we're only getting satellite updates every hour. So that should also tell you when this occurred. You know, we're used to our very nice 5-minute, even 30-second imagery nowadays, but that wasn't always the case. Hint, hint. So what do you guys notice about some of the clouds out here in New Mexico? What type of clouds are they?
Cumulus.
Yeah, it's cumulus. Yeah. So these are convective clouds, but we just saw that the dew points out there are pretty low. It's in that, you know, dry air mass. So these are probably high-based cumulus clouds, kind of along that dry line. You can see wherever you get those cumulus type clouds, you're getting ascent, you're getting instability. So that's kind of closer to the trough, but this is your dry air mass taking shape. Let's take a look down here too. Our stratus deck is pretty much totally eroded. I would argue that those are probably just pure cumulus clouds now. They're not really stratocumulus anymore. So you can change your cloud type as you go on through the day, you know, as you introduce heating. And I think our temperatures were, you know, what were they there? You know, they were in the mid 60s. So they're probably warming up through the 60s, maybe low 70s now. So you've really started to mix that moisture that we had, that Del Rio sounding, you know, you're starting to erode that cap, maybe starting to realize some of that buoyancy. How about further north? Hey, go back here. We mentioned last time that the billow clouds were, you know, they were getting more frequent or more numerous. What have we noticed about the southern end of that area now? Is it kind of look the same, or? I think I just heard somebody say it. Say it louder this time.
They're losing shape.
Yeah, they're losing some shape. Yeah, they're kind of transitioning. So notice how the eastern edge of the western edge of the stratus deck down here is changed into these cumuliform clouds. Now the billows are starting to kind of do the same thing. So remember, those billow clouds indicate stability, but they also indicate really strong shear. But as you go through the day, when you're starting to mix and heat that air mass, you start to destabilize it a little bit. So your billow clouds are actually turning into more cumuliform structures too. So this is another observational tool that you can use to say, this air mass is really sheared, and the southern half of it is also starting to become unstable. So be on the lookout for that. Okay. It's 16Z again. So now we've got another surface map. I think you guys have a 16Z map there. Yep, you got it. Okay, so go ahead and just do a couple minutes. Kind of the same thing we did with the first one. Look for your surface features and just be thinking about, you know, what's changed in the last 3 to 4 hours. You know, have my fronts moved? Are there more fronts? What does my air mass look like downstream of my fronts?
They're in the game, so it's when it increases.
I'm just saying.
Let me know if you guys want to see the satellite or past surface maps too. I can definitely step back in time if that'll help.
At least something. No, it's a 16. That's why it's starting out, you know.
I don't know, I mean, it's. I mean, well, yeah, it's gonna be something. The 60 million is also shifting from the southeast to the south, you know. You can see that. I just don't know that we would. Some moderate risk. Actually, I sort of yeah, it means something, but they're just in Australia.
Are we doing the Outlook update with this as well?
Yes, you are. So you guys jumped ahead of me, but yeah, feel free to change your Outlook. So you can change what you have on there, or you can leave it totally the same if you feel like you're in a good spot. But yeah, go ahead and update your Outlook at 16Z, and we'll go over it here in just a couple minutes. I think I will change mine as well.
That's
So everything, so you are, right, so now you're right. Yeah.
It's foggy and.
Yeah, just check it out.
I would, anything like this area. I've been seeing this Texas could be under a large. Yeah. Oh, no. Yeah. Oh, you got it.
You know exactly what's going
I knew it.
it.
I knew it.
I knew it, but you threw it, he's showing so. No, no, it's gone.
Oh, shoot, I deleted mine. Oh, no, you can't see it.
I see it.
All right, guys. What are we thinking now? Kind of, how do you feel after doing the 16Z map and after looking at how the data's changed? How do you guys feel about your forecasts?
Feeling okay. Quite a bit.
Feeling okay? Okay, and then feeling, someone said raising it quite a bit, I think is what you said?
Hey.
Yeah? Okay, what kind of nudged you towards like changing it or leaving it alone? What factors?
Boundary location.
Okay. Which boundary in particular?
Dry line.
Okay, all right, good, good. What factors have made people, I think I heard someone saying they added a moderate. Was that, actually, I guess I should ask, what's the highest category that you guys have now?
Enhanced.
Enhanced? Okay, all right, so we didn't jump up to it. Are we sure?
Nope.
Nope. Good. Yeah, that's how it's always going to be. You're never going to know. You talked about it. Why did you not change it?
Confidence with the information I have.
Okay. Yeah, that's a big one. You never quite know how that information, and obviously we're clearly limiting you here to make you use your other reasoning. But that's a big one. Yeah. Is there anybody that wants to downgrade or do anything different? No, we're all kind of settled in. So we still got some slights and some still an enhanced. Is that kind of wherever everybody's at? Because I could totally be messing with you in terms of the moderate and the high. I mean, I deleted all my stuff for a reason, so. Remember, it can still bust, so who knows? But real quick, with the surface map, did you guys notice any big changes on the 16Z versus the 15Z or earlier in the day?
Calvin said the dry line's more defined.
Yeah, the dry line's more defined. Yeah, we can start to see that better separation of the air mass. You know, you've got 20s, some teens out here in West Texas, and now you've got 50s and 60s to the east of it. So it's starting to sharpen up. Anything else?
There's rain, Southwest Oklahoma.
There's rain in Southwest Oklahoma. Is that what you said? Yeah. You've got drizzle right here at Childress, Texas, and you've got rain. I think that's Altus. Yeah. And then, yeah, a lot of low cloud cover. So you've got your warm front that was here earlier in the day has maybe shifted a little north, but you've got a bunch of rain and a bunch of, drizzle and low clouds that are hanging out over Southwest Oklahoma. Did anybody notice the wind direction in Amarillo and Lubbock? How has that changed since 13Z this morning? Did somebody say something? I think the mic cut out there. No? Okay, let's go back earlier in the day. What direction is Amarillo here? It's mostly southerly, right? When we get to 16Z, it's still southerly, but it's a little stronger. But Amarillo or Lubbock has flipped to southwesterly or southwesterly. So remember that shallow moist layer that we talked about? That might be the beginnings of the mixing that's starting to impact the moist layer there. So where might the dry line end up later if we're already starting to see some mixing in Amarillo, whereas we've got moisture and low clouds over here? So think about some of that. And here's a messy satellite image for your 1645. So this is like 45 minutes after you've done your outlook. So notice those billow clouds have pretty much gone away, but you still see the cumulus there, kind of along the cumulus streets. You've got a few high-based, cumulus towers and stuff like that out in eastern New Mexico, right where the dry line is. Your stratus has totally eroded over parts of south central and southwest Texas. So you're getting full sun now for the next couple of hours. And if you just kind of look in these areas, you can actually see the air masses colliding. I hate that terminology, but you hear it all the time. But you've got your warm, moist, southerly air coming up in here, and then you've got the dry air coming out from the southwest and eastern New Mexico, and it's kind of setting up in and around here. And I didn't go all the way down here too, but you're clear down there as well. Okay, so we already did this. Based off recent trends, did we need to adjust the outlook? You guys have already mentioned that some of you thought about it, but you've kind of left it alone. Okay, so now I'm going to introduce another fun wrinkle. So you guys get to issue watches too. So based on the satellite and the surface data, you guys can draw watches when you feel like you need one. If we go to this Outlook page, so for you guys that did your outlooks on the computer, if you go to watch mode, you can actually select a polygon and you can say, I want, so just say a tornado watch. You can draw a polygon and it'll highlight the counties in there too. And then you can click them on and off as you go in. So, and for you guys that are drawing on the paper, just draw like a square where you think a watch would be needed if you want to issue one. You don't have to, but each hour we'll stop and look at data, and then you guys get to issue a watch. So does that make sense to everybody?
Yeah.
Okay. And when we stop and issue a watch, we'll ask what type of watch, what kind of hazards you think are there going to be, and that sort of thing. And then we'll talk about where you drew it and why. Okay. Here's 17Z. So it's been an hour since we last talked about stuff. I'll just summarize really quickly. The dew point at Amarillo has fallen a little bit again. We're still southerly, but Lubbock has actually gone back to southeasterly and their dew points have risen. But everything out here, the dew points are falling. It's in the 60s with dew points in the 20s. there's a 50-knot southwesterly wind there just east of El Paso. So that's our dry air mass kind of kicking in. Got southwesterlies here, it's 72. Pretty good boundary kind of starting to show up in and around that Lubbock, Amarillo area, kind of down towards Midland, El Paso, kind of in and around there. So we'll just mark that. Oh, that's terrible. I'm sorry, guys.
Wow.
That's the worst dry line I've ever drawn. We'll just say for that, we'll just leave it at that. And then maybe a warm front somewhere in and around there, maybe like Red River-ish, even a little further up, something like that. Okay.
I feel like
Okay. All right. Here's your 17Z surface map, or sorry, satellite. What do we notice?
Cumulus.
Yeah, there's a lot of cumulus. Where are you kind of looking?
The dry line.
On the dry line. Okay. Yep. Yeah. So we've got our first cumulus towers kind of deepening over there. We're kind of starting to clear out here in that Oklahoma, Texas zone. You know, that's where our billow clouds were earlier. So strong shear. They've kind of transitioned to that cumulus. They're still there, but they're starting to clear out even more. And there's even some more cloud breaks kind of in the main stratus deck where we had the rain earlier. Ooh, what do we notice about the cumulus right here? Is that pretty tall or pretty short?
Tall.
That's pretty tall. Okay. So we've heated up. We've got our trough coming out. It's pretty strong. We know it's getting stronger. We've got a strongly sheared air mass. Is anybody thinking about issuing a watch now at 1745Z?
Yeah.
Yeah. Okay. Or did you say you issued one the previous hour?
In an hour.
Okay. Okay. Gotcha. What type of watch are you guys leaning?
Severe.
Oh, okay. All right. I heard 2 or 3 severe thunderstorms and then 1 tornado. Let's go with the severe thunderstorm people first. Why severe thunderstorm?
Because that would probably be the first watch issued, starting with the storms, because you know that with high cumulus clouds or cumulonimbus clouds, you're probably gonna have lightning and or hail, which also indicates severe weather.
Okay. All right. So you're thinking mostly like a hail and maybe wind threat early with this stuff, right?
Say early, especially since you don't wanna scare people too much straight off the bat.
Okay. All right. Yeah, that's a perfectly valid reason. You think this is what's going to happen first, and we're not sure. So let's go with severe thunderstorm. Yeah, that's great. Now for the tornado watch people, what are you thinking?
Lots of directional shear.
Okay, lots of directional shear. So you know the air mass is strongly sheared. So would you expect other hazards with this, or?
Also hail.
Okay, also hail. All right, cool. Anybody thinking damaging winds or anything like that? Yeah, I saw some head movement. We're not sure. Still not sure. We don't know. This could all blow up into a giant squall line, right? That's always fun to chase. Say that one more time. I think the mic cut out.
It was just laughs.
Oh, it was just laughs. Okay. Yeah, it's just my internet over here. We live in Oklahoma. We just got electricity last week, so
Yeah.
No, that's awesome. I think that's good reasoning. Whereabouts do you guys have your watches? Give me a rough estimation, like Texas, Oklahoma, or like Texas Panhandle.
From I-40 down to Central Texas.
Okay. All right. Well, we can telestrate that. We have the technology. All right, something kind of like this.
Yeah.
Ish. Okay. All right. And is that a severe or a tornado watch?
Tornado.
All right, you'd say tornado. Okay, we'll label that one as tornado. Oh, man. Oh, there we go. There we go. We got this. We got this. That's a tornado watch right there. Okay. For the folks that had the severe thunderstorm watch, are you guys thinking the same general area or slightly different?
I'm thinking the same general area, but expand it west, oh, it's not west, well, expand it east a little bit more on top.
Okay.
of tornado watches.
Okay. That sounds good. We can definitely do that. So we'll expand it a little bit. You tell me when. Right there? All right. So we'll include DFW. Most of oh, wow. I'm screwing that up. Sorry.
It's good enough.
All right. Perfect. That's our severe thunderstorm watch. We are professionals here at the Storm Prediction Center. Severe watch. All right. Okay, is everybody happy with that? Okay. Did anybody not feel like issuing a watch yet? Did you want to see more data?
Yeah, I wanted to see an extra hour of satellite.
Okay, all right. So we got a couple of people who are holding out. Sounds good. Okay, so let's keep going. Oh, I guess it's not quite the same shape, but you get the idea. It's 18Z. Here's the surface map. I guess if you can read it, we'll just delete all that. There we go. Any big changes that you guys see?
That one seems even better.
Yep. Yep. How about the moisture too in like South Central Texas?
A little bit further north, you now have 60 at the Red River.
Yep. Yeah, you got a 60 right there. Gosh, that's probably Wichita Falls area. So your warm front has probably lifted up north of the Red River. It's probably sitting just to the north there. So you're getting some better moisture that's coming in. Upstream, it's still, 62. It's a little cold, but you've got a warm front there. Just throwing this out there too. Are warm fronts known for having more low-level shear or less low-level shear? More. Yeah, that's right. So that can sometimes be a zone of interest when we're forecasting for severe weather, is areas where we get localized more shear along a boundary, things like that. So I know we kind of zeroed in on two separate areas kind of down in southern Texas and then one up along the Red River. So, that's something to keep in mind. Another thing that I noticed was the winds are a little bit stronger. So down in South Central Texas, you've got, 20 gusting to 25 now. You've also got on this OB up here, it's CB. So that's cumulus in the OB. So they're detecting thunderstorms in that area now, across, parts of Childress and Southwest Oklahoma. You're even getting some good gusts out west too. You don't see that barb very often at the surface. That's a 60 knot wind gust or 60 knot sustained wind there in the Davis Mountains in West Texas. So that's a really strong dry line that's shaping up. Even though the gradient is not super strong yet, the winds and the low levels are really strong. So if you don't have thunderstorms already initiated along the dry line, it's probably coming pretty soon when you see that sort of convergence. You've got winds of 60 to 70 miles an hour out here running into winds of 10 to 20. That generates that convergence that then lifts the storm. So you're probably starting to think, okay, maybe we have storms pretty soon in the next hour. So for those people who haven't issued the watch yet, I would pay attention for this hour. Okay, here's the satellite. Well, I guess the satellite is almost an extra 45 minutes, so you're getting cheated a little bit. People who don't have a watch, do you want to watch yet?
I have a watch now.
You have a watch now? Okay. That's probably a good idea. There are kind of some hints that you were going to get storms, and that's actually what these are. So that's probably already a thunderstorm. These are probably already producing lightning, especially that guy right there. But this general kind of cumulus kind of shape, you're already probably expecting storms, or even storms back in the dry air across New Mexico. And now you've actually got warm advection storms all the way along the warm front in southeast Oklahoma. You've got a storm in southwest Oklahoma. That's that CB reported by this. And then they're also reporting all this. So you actually have thunderstorms all the way back into Amarillo too. So we were worried about Amarillo not, getting enough moisture and not being enough, unstable enough, but you actually do have storms there right now. But just to the west is where that dry air mass is. So you're getting a lot of convergence along the dry line. If you notice down here to the south too, you're starting to get some cumulus. So where that strong low level push was, and then the air mass ahead of these storms has really cleared out. So you've lost all the stratus kind of in this area. You're getting that good sun. So you're rapidly destabilizing. So does everybody have a watch at this point? Yep. The person who just issued the watch, what type of watch did you issue?
Tornado.
You went tornado? Okay. Any particular reason? Or just felt like it?
We know from earlier that we have the shear in place. Through some satellite features we saw. I like the chance of maybe some supercells.
Okay. Yeah, perfect. Yeah, that's definitely a strong consideration. Anytime we're issuing a watch, we want to know storm mode. That's the biggest thing. If we expect supercells and strong low level shear, that automatically has us thinking tornado watch. But if we expect a squall line or messy storm mode, that sort of thing, we might lean more towards severe, even if the environment may support a tornado or two. So, but both of those watches and ideas are perfectly valid. And I'll give this to you too. You can actually upgrade and change the watch type as you go. So each hour, we'll say, I think we now have a couple tornado watches and a couple severe thunderstorm watches. Does everybody want to keep theirs the same?
Yes.
Yes, I heard mostly yeses. So is that good with everybody? We're good?
We take a little bit of the area of thunderstorm watch and start putting in a little bit of a tornado watch.
Okay, cool. Yeah, you want to, which area? Which part?
The area that's kind of closer to the dry line up until the Red River.
Okay, like say,
Close to what the tornado watch people were saying earlier.
gotcha. That sounds good. How about, oh man, sorry, I keep messing this up. All right, so we've moved the severe thunderstorm watch part towards like a tornado watch in this area, something like that.
Yeah, for the tornado, and keep some of the other area, the thunderstorm watch as a thunderstorm watch.
Gotcha. That sounds perfect. And we actually do this sometimes. We're supposed to be getting the capability in the next couple of years to kind of change watches in increments or just slowly. It's called amoeba watches, because if you think of the amoeba, the single cell organism, they move slowly. So we're going to try and do that with severe thunderstorm and tornado watches in the future. But yeah, I like that idea. Okay, let me clear that. Okay. It's 19Z. Here's your surface obs. We seeing anything different? Anything that jumps out at anybody?
Yeah.
It looks like the dry line is progressing east, especially in Midland there where they mix out.
Yep. That's a great call. The dry line has started to push east. You've got what's called a dry line bulge right in there. So you've got a section that's bulged out further than the rest of it. You've got thunderstorms reported in Amarillo and Lubbock. Got some drizzle and rain in Oklahoma still too. Yep, and there's a thunderstorm down in Ardmore. What do we notice about the winds along the Red River? They're pretty backed, yeah. So they're more easterly than they were previously. What does that do to our low level shear? Increases it, yeah. And so we've already decided to move some of the tornado watches in there. We've upgraded the severe thunderstorm watch. I think that's probably a pretty good call based on the environment. We know we have storms moving into a pretty strongly sheared air mass. Is it super warm? No, it's not super warm, but we got some good moisture, but when we get back to that trough, it's pretty cold aloft. So we've got the steep lapse rates. You don't always need really good deep moisture whenever you have steep lapse rates from a deep trough. So that's something to think about too. For our southern target area, we've warmed up into the 80s. We're pretty good now, 80 over 54, 80 over 64 down here. Sorry, 81. Dew points in the 70s down in this part of Texas. So we've got some juice down here. We've got some really good juicy air kind of moving up in here. Okay, satellite time. What do you notice about the satellite presentation now?
Mature storms,
Yeah, they're mature. How can you tell?
large anvils.
Exactly. Yeah, you've got a lot of anvil that's already spreading over there. They're wide, they're tall. What type of storms do you think these are?
Supercells.
Supercells, yeah. You can kind of tell they're individual storms. You can see the individual structures. They're not necessarily in a big line. They seem reasonably well spaced apart. It's a little hard to tell. There's no radar data. That would be cheating. So all the radars have gone down that you can't access them. Yeah, I know. Darn. But you've essentially got supercells here and moving into that environment where you've got a bunch of low level shear. So I'll ask, how are we feeling about our watches? What type of watch do we think we want over there? Tornado. Okay. I'm going to even throw this in. Are we okay with just a base tornado watch? There is something called PDS, particularly dangerous situation. Is anybody interested in that? That kind of what I'm hearing? No, you're not sure you don't want to go PDS yet?
Yeah, give us the reason.
That might be too late.
Yeah. I'm not giving you enough data. You don't have any UH tracks. You can't go PDS without that, right?
Data.
Yeah.
For severe thunderstorm watch, we've upgraded part of it. Do we want to keep the rest of it severe thunderstorm watch and just keep the tornado watch going?
Gonna update the rest to tornado.
Okay, you want to update the whole thing. All right, so it sounds like everybody's got a tornado watch, pretty much all of there into Texas and Oklahoma. And what do we know? Some tornado reports came in just a couple minutes prior to this. We had an F0 in Plainview, Texas. We had a F0 in Crosby, Texas around 1908. And these are just the two storms that stuck with those. Okay. 20Z. I'm going to start to go a little faster. What do we notice about the dry line in Amarillo, Lubbock, those areas? Has it already gone through?
Yes.
Yeah, it's already gone through. We've got the southwesterly winds. The dew points have dropped. How are we doing in Oklahoma? Much change compared to before, or pretty much the same? Pretty much the same. Yeah, it's strongly sheared. You got the back to low level winds. I did notice the low level winds out here have picked up a little bit. They were around 5 to 10 knots before. Now they're about 20 to 25 out of the south, almost due easterly in some spots. So more shear things. Further south, look how far east our dry line's gotten. It's all the way over here now. We've switched to southwesterly in this area. So our dry line kind of runs like this. So are we thinking maybe some storms down here too later? We're still not sure.
There's a good chance.
Good chance? Okay. Yeah. I like that. Let's take a look at the satellite. All right, do we still have supercells?
Yeah.
Yes.
Yeah, I think we probably do. I can count 1, 2, 3, 4, 5, maybe the beginnings of a sixth in there. So we've got some pretty good storms going on. There's a bunch of convection now over Oklahoma. This is all probably north of the warm front where it's a little colder. So what kind of hazards would we be thinking with these storms up here north of the warm front?
Yeah.
Hail. Yep, perfect. That, you know, it's not surface based, but there's probably still strong storms. We know that air mass now is unstable. That's the same air mass that's ridden up over the cold air there at the surface. Whoa. That's a 30-mile F4 with 11 fatalities in I guess north central Texas. I guess I should have asked you guys, what was the maximum tornado rating you were thinking before or when you issued your outlooks?
4 or 5. Famous for 4 or 5. Oh, it's in, you know, that's 4 or 8.
Yep. Okay, so I heard some lower ends and then some people saying 4 and 5. So yeah, you ended up with an F4 there. Okay, 21Z. Any different there in southwest Oklahoma, north central Texas?
Not much.
No.
Nope. Yeah, it's pretty much the same. Storms are right there on that warm front corridor. We know they're already tornadic. You guys want to update the tornado watches at all?
Downstream.
Okay, you want to go downstream a little bit? Yeah. How far east do you think?
Few counties.
Few counties? Okay, so like maybe to I-35 or something like that?
Yeah.
Yeah.
Okay. Sounds good. Okay. Satellite difference. Not a ton, right? You got your big Anvil Cirrus. You've kind of lost some of the storms there. They've probably crossed the warm front into the colder air mass, so they're probably going elevated there. But what do we notice back here?
Great.
Yeah, we've got more discrete development. So you've had more storms able to develop. We haven't seen a ton down here along the dryline bulge. It's all been mostly to the north. There's a few hints at convective development here, but overall the environment down there is still just not mixing as much. But we've got new storms down here. Where do you guys think the greatest tornado threat is the next hour or two?
Wichita Falls.
Wichita Falls, okay. We don't know this case already, do we?
No.
No? Oh, man. Well, you might.
I just know my geography.
Ah. There's a long track F2 tornado that occurs just northwest of Wichita Falls. There's one fatality. So that's with that main storm there. A lot of the other storms have crossed the warm front now, but there still are tornadic storms along the warm front. Okay, 22Z. What do we want to do with the watches? It's been another hour. Do we want to push east a little bit further or leave them the same?
Push east.
Okay, all right. So how about right here, this area? A little east of I-35.
Right here, whatever that next highway is, I can't tell what that highway is with the red one, yeah.
Okay, all right, we can go out there. I actually don't remember what that highway is either. So
You're the Oklahoma guy, you should know.
I know, I should know. I'm bad. I don't chase down there. So so yeah, the only thing that I noticed was the dew points have really filled in. I know to start the day, the moisture wasn't great up here, but we've got a 63, we've got 64s and 65s now, just north and west of Dallas-Fort Worth, some 60s and 70s. The clouds have cleared out and the winds are really strong. You've got 25 gusting to 33 knots. So you've got a really strong low-level jet kind of working in there. And where did look what our storms that were out over here, they've continued east. We've got nice and mature now. I think our tornado watch is a good call. Because there's an F3 in Lawton, Oklahoma, actually north of the warm front. Oh, there was supposed to be another update there. There's a few other tornadoes that occur in this area. But these storms need a little bit more time, but there are several other tornadoes that occur right in around here. Okay, 23Z, we got the tornado watch all the way out here. How are we feeling about that one? Keep it where it is.
Yeah.
Okay. It's cooler. We haven't seen much change in this air mass over here. The dew point there in Paris is 32. That's probably not great. It seems like the front kind of stops in and around here, so we might want to leave that alone. Oh, there's
There it is.
a tornado in Wichita Falls, Texas, at 2350. So that was that storm that initiated around 22Z. It tracked all the way up there. It's just south of the warm front. It feels that zone of stronger shear. Produces, I think it's a 35 or 40 mile F4.
Wow.
Yeah, this is the same thing.
Yeah, so did anybody know the date? Or were you able to figure it out?
No. Say which one. I have a feeling it was on the which one.
Yeah, this is what's called the Terrible Tuesday outbreak. It's April 10th of 1979. So, like I said before, there was no model data, so I couldn't give you any model data, which made this case really easily for me. There were no radars. So there was one experimental radar here at OU that kind of caught some of it, but all that data is analog, it's not digital. So yeah, this was the tornado watch that the precursor to SPC, the National Severe Storms Forecast Center, or NSFC. You may have also heard it called CELS. This is what they issued at 2:30 p.m. So gosh, when was that? 1930Z. So even they were a little bit late. They had the first couple tornado reports before the watch came out on that one. And then you can see some of the radar data. So it was a messy storm mode. There were several supercells kind of clustered together, but they were discrete. They were able to produce big tornadoes, especially in that environment right along the warm front. Here's Dr. Ted Fujita's map of that. He drew these by hand. So there's that first Vernon tornado. That's pretty long track. There's the other long track tornado, and then there's the Wichita Falls tornado as well. So there ended up being 59 total tornadoes in Texas and Oklahoma. It was a big outbreak for, what that environment looked like. And you had tornadoes all the way up south of Norman too. So well north of the warm front. That happens occasionally when you have these really strong dynamic storm systems. They will produce storms that are able, develop in more favorable air masses, but then continue to produce tornadoes in air masses that are less favorable in terms of buoyancy, but they keep going because the mesocyclone is strong enough to overcome the low level stability. So that's something to keep in mind. The tornado watch, I think, ended like right here. So they did not capture the northeast extent of the tornadoes. And you can see some of the pictures on the right here. They were big, mean, grungy wedge tornadoes, kind of what you'd expect along a warm front where you've got low cloud bases, a lot of fog, that sort of thing. And then here is the tornado archive map. So you can see there did end up being tornadoes later in the day. It took until the evening into the overnight hours for storms to develop here. The dry line actually surged back west, and that's what initiated those storms there in central Texas. Does anybody have any idea why storms might have struggled to form there during the day?
Maybe a cap. Yeah.
It's capping. Yep, that's part of it. But where did we have our maximum in strong surface winds? It was kind of in that zone, right? What kind of air mass are we blowing from here over towards that part of the dry line? Is it dry or moist?
Right.
Really dry. So what you probably saw during the day here was issues with dry air entrainment. You're putting so much dry air right on the dry line that storms and cumulus clouds are struggling because they're ingesting that dry air, and it's literally mixing the clouds out. So that's something that may have affected that. And that process reverses at night where you have the strong southeasterly winds able to mix the better moisture into the surface. So once you had that reversal of the winds, that's when you were able to get storms to develop there. So that was kind of a red herring, and that's why I like this case a lot, because it looks like this is the best area. And this area has a lot of question marks early, but this ends up being the main tornado outbreak with those. So there's an awesome review by the WFO in Norman. They talk about this. So there's the link if you want to see that. There's a couple videos too. These were some really well captured tornadoes. This was a really significant outbreak for the time. This kind of spurred the development of the next generation weather service radars, because the test radar in Norman captured the data so well. The weather service, or the Weather Bureau at the time, realized, wow, we really need this to forecast tornadoes in the future. So that's part of the reason why there are so many weather service 80ADs around, is because of this outbreak. And yeah, and I can annotate some of the stuff, the main features. So there was that trough that we talked about, several jet streaks kind of involved in that. So anywhere you have those jet streaks, you've got better potential, or vorticity advection and better lift. Then you have a really strong jet streak coming in on the 500 millibar trough. So this would help deepen the trough and kind of make it take on a negative tilt. And then all of your lift and diffluence, the air spreading out with time, was centered right over this northern area in Texas and Oklahoma. There's your warm advection and your cold advection. Remember, the cold advection increases the strength of the trough. Your warm advection causes rising motion. You've got it right there in that whole zone. There's some of the fronts, there's the lows. There was a weak surface low in southeast Colorado, but it ended up really strengthening later in the day. And that's what drew that warm front north so quickly. And then here's just a couple of the surface maps. This is kind of probably a surface pressure trough. There was a wind shift there through the whole day. And this is probably your dry line that we talked about early on. It doesn't become super clear until later in the afternoon, when you get the warm front and the dry line really kind of keying in on this area, kind of Childress to southern Oklahoma. But those were the main features that you really saw that kind of tipped you off. And if you looked up here in Colorado, the low actually got down to 992 millibars. So that ended up being pretty strong. It did not start the day that strong. So this is a really dynamic and quickly evolving storm system. It occurred early in the year. That was another hint that I was trying to give you guys, is that these early year systems, or early in the month systems, tend to be more dynamic, and they can change really quickly, the environment that goes on. So that's the end of the case. I hope you guys kind of had fun with it. It's a really fun one. There's a lot of research on that one. If you have any questions, we can talk about it, or talk about SPC and forecasting in general. There's my email. So feel free to shoot me an email anytime you guys have a question. And then there's my Twitter handle as well. Feel free to add me and send me messages, or anything that you guys like. But I just want to say again, thank you so much for having me. I really wish we could have done this in person, but I hope you guys enjoyed the case. And yeah. Thank you. Thank you.
One quick question. Does it usually take you guys quite a while to do these forecasts on a daily basis on a severe weather day as well?
Yeah, I'd say it takes, on average, to do an outlook, probably 3 hours to look at all the data, set your lines how you like them, and then write the actual discussion. I think a lot of us kind of are looking at stuff before we come in and the days before, to really kind of have an idea. The whole forecast process for me, when I'm on the desk, starts probably 2 to 3 days before an actual event, where I'm checking data, following up with it, seeing how it's changing. And then the day of, I'm doing that, but just at a faster pace. So yeah, it takes quite a while.
If you guys, I know it's late, so if you guys have any questions, maybe stick around or take a picture of the contact information there. You guys like the forecasting stuff?
Yeah. Oh, yeah.
Would you guys be interested in like a club of this?
Yeah.
Yeah, would you guys come to a club up there? Okay. So yeah, if you guys have any questions, maybe stick around or take a picture of that, but that's what we've got for you tonight. So one more round of applause.
Thank you, guys. Thank you.
Okay.
Disperse.
First.
Thanks a lot. That was really cool.
Yeah, no, thank you guys for having me. It was awesome, and you guys were super engaging. I was worried me being online, the distant remote voice would be kind of crappy, but it worked out. You guys are awesome, so thank you.
Yeah, thank you very much.
I'll hang around if anybody has any questions or anything, but yeah, feel free to email me anytime. And like I said, if you guys are ever in Oklahoma, let me know. I'd be happy to sit down, meet with you guys and show you SPC and all that.
Yeah, awesome. That'd be great. I'm sure we'll be down to Oklahoma.
Yeah.
We will.
What's the best time you recommend we head down there for some
Should we turn?
chase vacation?
Let's Alvin.
Oh, there we go. There we go. Hello.
Did it work?
I would say definitely May. May is the best time for chasing. Usually we've got the HWT, the hazardous weather test bed, in May too. Just depends. I know you guys have exams like the first part of May usually. I usually take off like close to the last week of May. That's usually my favorite time to chase.
That's what we did this year. Yeah, we left on like May, what was it, 22nd?
Yeah, and we were in Clovis every day.
Week where it was like Grady, New Mexico, Grady, New Mexico, Clovis, New Mexico.
Tucumcari. Yeah.
Well, hopefully it's not New Mexico summer camp again this year. I don't think it will be.
I wouldn't mind.
I need you to give us one of your classic dry lines because I've yet to see a pretty tornado, and I better get it in May in Oklahoma.
Tell you what, plan to come out this year. I'll see if we can get a chase together, and we'll find a dry line day. How about that?
Yeah.
If not, we can convoy, and we will figure out.
Well,
There's also fun stuff to do in Oklahoma, believe it or not.
you have to text Chris and tell him to issue a high risk. Loves his high risks. You know it's got to be there.
He loves his high risks, and he's a big chaser too. He loves to chase. So yeah, I would love for you guys to come in and meet Chris. He is super awesome. So.
But nothing can beat your March 31st upgrade in Illinois. You had us all on the edge of our seats with that mesoscale discussion.
And then I hit you with the two, the double punch. So that is epic lore in SPC. That's the first time we've ever done that with two of them.
Yeah, that's crazy.
Yeah, on the day one, and we had the same thing. We knew we were gonna have, because we did the southern area first, and I'm like, oh, they're not gonna expect the northern one too.
Okay.
We've got one question over here.
Sure.
This is
So,
Brandon.
how did you get into pathways, I guess?
So Pathways started that first year. I was a junior. So the school made an announcement that they were doing the Pathways program. So I'm hopeful that you guys as admin might be told about that. But they just told me, hey, we're doing this program. It could lead to a full-time job as a forecaster, which is what I wanted to do. So I just applied. The first year they did it, you could actually apply to every single office. So I did apply to every single office, all 122 of them. So I think now you can only do 5 or 10. But yeah, I would ask if you guys have like an admin coordinator, or I can even check too if you guys, when the announcements come out, it's usually around this time, to sometime around January or the first of the year, that the Pathways program announcements come out, and it's open to anybody, sophomore and above, even graduate students too. But yeah, I would strongly encourage you to apply. Also reach out to the local office, in Romeoville. So Brett Borkart there, he's a lead forecaster. I went to school with him, and he also did the Pathways program. He would be a good person to contact if they have any openings and stuff like that.
Okay, thank you.
Yeah, for sure. And I'll try and keep an eye out if you guys if I see the announcement, I'll send it to Kelvin and your board, and I'll try and pass it on to you guys.
Very nice.
Great, we appreciate that.
Yeah, for sure.
Okay, any other questions?
I've got one. How many of y'all are interested in like NWS or operational forecasting? Okay, cool. Yeah, no, that's great. That's awesome. That's what I want to see. There's so much you can do, and you know, you can do research and stuff too while you're working and stuff like that. I'm working on a bunch of different projects right now, so it's definitely an awesome opportunity if you guys can get it. It's good pay when the government's not shut down.
What would you say to people who are worried that they won't be able to chase if they have an operational job?
Oh, you get 3 weeks of leave every year. Yeah, like if as long as it's not your, well, actually, even if it is your area, if you take leave, which you can, I've chased every year that I've been in the weather service, sometimes multiple weeks. So, you know, you get a bunch of PTO that you can earn and use however you want. So yeah, don't be afraid of that. You can totally chase as much as you'd like.
Go get yearly tornadoes.
Yeah. I do. So get your yearly tornadoes in. And chasing, I think, makes you a better forecaster because you see those processes in real time. You have to be good at forecasting to make your your chase targets work. So obviously be safe and you know, always chase with a buddy and follow the rules of storm chasing, but it definitely makes you a better forecaster in my opinion.
How far in advance do you have to put in your leave?
It depends on the office. Some people are really good, you know, with like, you know, a month in advance. Typically the schedules are done like 6 to 8 weeks in advance. So you usually know what you're working. Kind of in the summer, there's peak leave periods where you get, you know, kind of after Memorial Day through like the 4th of July, or through Labor Day, that's a peak leave period. So typically you have to do those a little bit early. But yeah, I'd say it depends on your office. I try and do mine no later than like a month in advance.
Okay.
Yeah. So I guess you can't do some of the local setups, like if it's like, oh, it just came out of the blue, unless you're on an off day or something like that. But you can always swap shifts with someone. If someone likes working severe weather at the office, say, hey, do you want my shift? And I'm going to go chase, and you can do radar and stuff like that. So you can definitely make it work.
Cool.
Does anybody have questions down the line? No. No, anybody got questions back there? No. No. Okay, let's talk about that dry line meetup in Oklahoma. Okay,
Well, thank you guys for coming.
yeah.
If you have any questions, just in the Discord or email us per usual.
And the meeting tonight is recorded, so it'll probably take 5 hours to upload to YouTube. But
Yeah, sorry, it's a little long.
yeah, no, it's fine. Yeah, in the recording.
Where's the button? Okay.
Oh, up there,
Is that
the
it?
little square.